Welcome to the inside story on the immune system. This weekend, our niece Yvette has come over to visit with us. She and Eve are in the family room right now doing the crossword puzzles. Hey guys, how's it going in there?
Aunt Eve, this crossword puzzle is tough. I'm still stuck on 4 down. It has 8 letters meaning exempt from detrimental effects. It begins with an I and the 5th letter is an N.
Ouch!
Try impunity or immunity.
Well, they both fit, but I'm not sure I understand very much about either one.
You know how some international representatives can park their cars and never get towed? That's impunity.
Oh, that's not impunity. That's diplomacy. This is impunity.
My fellow Americans, let me make this perfectly clear. I am not a crook.
Nice job. You didn't know your Uncle Adam was an impersonator, did you? Should we give him immunity from the critics?
Oh, pardon me.
Adam, maybe we should just teach our favorite niece about biological immunity and the human immune system.
Yvette, I'll give you an overview of immunity. Then, if you really want to study its essentials, you can view the immune and lymphatic systems more comprehensively in your school library.
Okay, Uncle Adam, let's get the inside story.
For human beings, biological immunity means being protected from disease. What you see before you is not just your loving uncle, but a battlefield. Every day there are constant battles being waged between my immune system and countless foreign germ invaders that want to take over my body.
Could you be a little more specific?
Actually, I have 2 lines of defense against foreign invasion. It's called non-specific immunity. For example, my unbroken skin is a formidable non-specific defense mechanism. Also, when I cough or sneeze, my mucous membranes are defending against invasion by all foreign organisms as opposed to specific organisms. The same thing happens when I release acid in my stomach. The digestive chemicals are another line of defense.
Does that mean that every time your stomach growls, you're being a war hero?
Well, now, I'm immune to that comment, Pilgrim.
Sorry.
The first time my body encounters a new foreign invader, the only immediate response I can have is nonspecific. If that invader gets past my first line of defense, I have other nonspecific mechanisms. For instance, my white blood cells will attempt to surround, ingest, and destroy it. The cells which carry out this process are called phagocytes, which means they like to munch on other cells and can ingest bacteria and other foreign invaders. You can see what this looks like for yourself by clicking on the picture. The blue cells with irregular shapes are macrophages, one of 2 classes of phagocytes. Macrophages are scavenger cells that can ingest dead tissue and foreign cells. The macrophages form tentacles called pseudopods to surround them. Once inside the macrophage, the invader is walled off and then digested and destroyed by a bag of digestive chemicals, or enzymes. That's how phagocytosis kills invaders the first time my body encounters them. If my body sees that invader a second time around, I can use my specific immune defenses. And even though the invader may have only attacked me at one local site in our previous encounter, my entire immune system can react to seeing it again.
How can your immune system remember that?
It greatly depends on a type of white blood cell called lymphocyte.
Lymph who?
Lymphocytes. These are formed in lymphatic tissues and are actually part of a larger system called my lymphatic system, which includes lymph nodes, the spleen, and the tonsils. Your Aunt Eve can talk to you later about the role of the lymphatic system in the spread of breast cancer and other diseases. But in terms of immunity, the lymphocytes give our immune system its memory, as well as its ability to respond specifically to foreign invaders. To see the inside story on immunity, click on the picture. My immune system is comprised of specialized white blood cells, called lymphocytes, that adapt themselves to fight specific foreign invaders. These cells develop into 2 groups in my bone marrow. From there, one group of lymphocytes migrates to a gland called the thymus and become T lymphocytes, or T cells. Within the thymus, my T cells mature under the influence of several hormones. When matured, the T cell types are ready to work together to directly attack foreign invaders, providing what my physicians call cell-mediated immunity. This type of immunity is deficient in persons with HIV, the virus that causes AIDS. The other group of lymphocytes, B lymphocytes, mature and develop within the bone marrow itself. In that process, they achieve the ability to recognize specific foreign invaders. From the bone marrow, B cells migrate through my body fluids to my lymph nodes, spleen, and blood. Because the Latin word for body fluids was humors, we still say that B lymphocytes provide us humoral immunity as they circulate in our fluids in search of specific foreign invaders to destroy.
Dr. Harper, what is the difference between HIV and AIDS?
HIV stands for Human Immunodeficiency Virus. This virus weakens the immune system, which is the body's main defense against disease. HIV attacks certain white blood cells that fight infections and tumors. AIDS, which stands for Acquired Immune Deficiency Syndrome, is the result of the destruction of these white blood cells in the immune system.
How does HIV affect our immune system?
HIV attacks a specific white blood cell or lymphocyte called the CD4 lymphocyte. CD4 lymphocytes prevent certain infections called opportunistic infections from taking advantage of a weakened immune system. If the body does not have enough CD4 lymphocytes, infection or various kinds of tumors may grow in the body.
How is AIDS spread?
AIDS is spread mostly through sexual contact and intravenous drug use. In some cases, transfusion of blood or blood products has also spread the virus. AIDS is not spread through casual contact, shaking hands, hugging, or normal contact at school, work, or home. Education about AIDS transmission and prevention is vital to slowing down the spread of this devastating disease.
Nice explanation, Adam. I feel like Dorothy in the poppy fields. Sleep, sleep, sleep.
Well, your explanations are so very interesting that maybe you'd like to tell her about vaccinations. Maybe I could give you a shot in the old...
Never mind, my love. You were saying...
Vaccinations are a part of a strategy. My doctor uses them to provide me with a memory against a specific invader or antigen that I might have trouble fighting off the first time it attacks me. You know, like measles or smallpox or diphtheria. Vaccines may contain specially altered live antigens, or they may be comprised of dead or weakened antigen parts. In either case, the vaccine helps create a cell-mediated memory that we can use to fight off the full-strength invader if we are attacked by it. To see the inside story on vaccinations, click on the picture. Ouch! Vaccinations are injections of antigens into the body. The antigens in the vaccine are those little green guys. Once they enter my blood, you can see them circulating, along with my B and T cells. As the antigens invade my tissues, they attract the attention of my macrophages, those nonspecific scavengers I mentioned earlier, and get eaten by them. The macrophages signal the T cells that antigens are invading. The T cells respond by attacking the invading antigen. Finally, the suppressor T cells stop the attack. The end result is that after a vaccination, I have a lasting memory of an encounter with a potentially dangerous invader, and hopefully have a better ability to fight it off if I'm ever exposed to them again in greater numbers.
Cool. So it's kind of like getting a pre-test in school. You learn about the questions, you figure out all the answers, and remember it for the real test, right?
Well, yeah, I suppose it is cool.
So, the stronger our immune system, the better off we are.
In general, yes, but with the immune system, there can be too much of a good thing. It can overreact to certain foreign invaders, as in the case of seasonal allergies or bee stings, and it can also react against our own bodies, which results in what doctors call autoimmune disease. For instance, my allergy to pollen each spring is a very unpleasant immune system overreaction to a memory of previous pollen encounters. You can see it by clicking on the allergy animation.
Dr. Harper, what causes me to sneeze when I'm allergic to something?
That something you're allergic to is called an allergen. If an allergen gets into your nose and lands on the mucous membrane inside it, the allergen will trigger a series of reactions. Basically, the cells lining the membranes release chemicals that attack the allergen. A side effect of these chemicals is membrane irritation. Sneezing is the body's way of responding to the irritation by forcefully removing the chemicals from the mucous membrane.
Allergens, like pollen, are nothing more than foreign plant antigens. When they get released into the air, you can see and hear the result.
Or get sprayed with it if you're standing in the wrong place. As part of Adam's nonspecific immune defense, the stimulus for sneezing gets triggered when allergens first enter his nasal tissue. Pollen allergens encounter the plasma cells in his nose, which respond by producing antibodies. These antibodies attach to his mast cells, which are white blood cells containing the chemical histamine. As more antibodies are produced, they cause the mast cells to release histamine. Histamine then produces Adam's allergy symptoms. His stuffy and runny nose, sneezing and watery eyes not only give him seasonal charm, but help to remove the invading pollen. The effect of histamine is sometimes so bad that Adam takes medication called antihistamines to make his allergies less severe.
Gesundheit.
Come on, Yvette. Let's let Adam get some rest. We can go back to doing the crossword puzzle. Or if you want to learn about the lymphatic system and how it relates to the immune system, I'm available.